we're trying to prove that if we have a point in this parallelogram here, if we perform a transformation on that point, it's still going to be within this parallelogram if that point is made up of au plus bv. These are the two vectors u and v. Normally, if you add them up, you'd get this point over here. U plus v would be something like this. P equals, the point uv. If you sort of add up those 2 points, you get u comma v. But you could also scale it, so you could say P is au comma bv. If that scalar is only between 0 and 1, then it's still going to be within this parallelogram. So now we know that if we take this transformation of this point au bv, let's call it au plus bv, and then if we do that, it's still going to be within our parallelogram. Now let's try to find some ways to prove this. Well, the first proof that we can think of is maybe something like t. If we take the point 0 and transform it, it's definitely still going to be 0. So that's definitely one way that we can prove this. Another way to prove this is if you take the point u plus v and transform it, u plus v, you could just use the distributive property, and this will become tu plus tv. And so that's just another way that you could prove this. Another thing you can do is scale these. So you could say t and then au plus t and then bv, and you're scaling it from 0 to 1 over here. But then you could pull out the constants, and you could say a tu plus b tv, and that's going to be another part of this proof. And of course, if you wanted to, you could basically just set one side equal to 0, focus on just one side, and you would see that this is all consistent. And so that's another way you could prove this. So far, we have 4 ways to prove this. Now let's say we have this point x. Then this point x is supposed to be somewhere in here. Of course, that point x is just going to be equal to au plus bv. Now, if we wanted to prove that this point was still going to be within this parallelogram, we would just want to perform this operation on it, right? Because if you take t and then you go au plus bv, then you get that it's still within this parallelogram. So the key is to just go t of x, and well, that should still be within this parallelogram. Now, if we are to perform that operation, t of x, that would actually just become t of au plus bv. That's the next piece. This will simplify down and become a tu plus b tv. And that's the last piece here. Nice.